2419, longest subarray with maximum bitwise add. If this is a bit manipulation problem, so the most important thing is try to understand what is the meaning of the problem. So let's just try to understand it. So we are giving an array of nums and with integers, and the size is n, and consider a non-empty subarray from nums. So what is a subarray? Subarray is a contiguous sequence of elements within an array. So it means the element must be contiguous. And we're going to consider a non-empty subarray from nums that has the maximum possible bitwise add. And we should know how to calculate the bitwise add. It is just the bitwise add of all the elements inside the subarray. So in other words, let k be the maximum value of the bitwise add. So for this example, the maximum value is 3, and the longest length is 2, because this is 3 bitwise add, it is 2, and we cannot find a longer one. So we're going to return a result with 2. And for the second example, the longest is 1, because 4 is the maximum value, and this one going to be the maximum. If a 3 bitwise 4, it's going to be smaller. So for example, if this is 3, it is 1 1, and 4, it is 1 0 0. So it's going to be 0. So the longest must be 1, not 0 or not 2. Yeah. Now let's try to understand how to solve the problem. We should first calculate. So the first step is what is the maximum number for the subarray. The maximum number, as the calculation is a bitwise add, it means, so for example, the numbers will become smaller and smaller. Yeah, so if we have an array like this, so bitwise 1 and bitwise 2, so it's going to be 0 1, and bitwise 2 1 0. It's going to be smaller, so it's going to become 0. So for the next step, 0 with bitwise 3, so it's going to be 0. Yeah, so inside of the array, it's going to be smaller and smaller. So for example, inside of the array, first of all, it's going to be 1. If 2 and 1, it's going to be 0. After that, it's going to be 0. So yeah, so this is the calculation of bitwise add. But we should know about the maximum number of bitwise add inside of the subarray. It should be the maximum number inside the array. So for this example, the maximum number is 3. So this means 3 gonna be the maximum number, because 3 bitwise 3, it is still 3. But for the 3, if 3 were to bitwise a smaller number, it must be a smaller number than 3. It cannot be a bigger number, because 3 is the maximum number. So 3 bitwise 2, it's gonna be smaller. So 1 1 bitwise 1 0, it's gonna become 2. Yeah. So if we know the maximum number of 3, we just need to calculate what is the contiguous 3s. So we just need to list the group of 3s. So there are 2 3s contiguous. So the result would be 2. Yeah. So for this example, we should know that the maximum bitwise add should be 4, because 4 is the maximum element inside of the array. Now we just need to calculate how many contiguous 4s inside of the array. So there's only 1. So the result would be 1. So this problem just becomes a list group problem. First of all, we just need to calculate the maximum number, mx. And the second step, we just need to use the list group to list all the contiguous elements. For example, this is 3 and this is 4. Now let's just go back to the code. I'm going to use I equal to 0, and the result is also 0, and n is the length of the nums. And I also need the maximum number. It's going to be the maximum of nums. Then I'm going to use a while loop to list the groups. So while I less than n, and z should equal to I, and while z less than n, and nums z equal to this maximum number. So z would plus equal to 1. So the result would be the maximum of result with z minus I. So for example, z is from beginning, z is here, then z goes to next place, and then z goes to next place. So the maximum result would be z minus 1 with the result. but this condition is only if for nums I equal to the maximum number. Yeah, we're gonna execute on those lines, and after that I should equal to z, because the I pointer would be shifted to z. Otherwise, if we didn't find the maximum number, so the I should plus equal to 1. So finally, we just need to return the result. Now let me just run it to check. As you can see, it works. So the time complexity is O(n), because for here, this is a list group calculation, so this is O(n). And here, maximum number, it is also O(n). So the time complexity is O(n), n is 10 to the power of 5. That is why it works. Now let me submit it to prove that it can pass all the testing cases. As you can see, it's pretty fast and passed all the testing cases. Thank you for watching. See you next time.